Hey everyone, Umongus here, and I'm coming at you with the 8th and last part of our assembly code simulator. And the reason this will be the last part is because by this point, anyone watching is most likely already pretty proficient at C programming and will be able to continue doing stuff from here. So this next part will be about conversion to binary, and by this point, you should know how to export a text file via C, where it's going to convert our instructions into a binary format, which consists of zeros and ones. So over here, you can see these first 8 bits here being OP, which means operator, so bits 31 through 24. And then, for example, let's say 0 means all zeros means it does absolutely nothing. And then the 1 here, it probably does a display, or that'll be for a different thing. You could use this last bit to represent immediate, such as add immediate or subtract immediate. There. And then you could use these 2 bits for a few different ALU instructions. You could do 1-1 for the MOV instruction, or if it becomes 1-0, it could represent add. And then you could make subtract be 1-1. And then, with this last bit being immediate, then you could do MOV immediate, or in this case more so, since MOV already does immediates, you could make it do a display command when it's 0-1-1. Yeah, 0-0-1 still doesn't do anything, but yeah, 0-1-1 does move immediate, which would be display, and then 1-0-1 add immediate, 1-1-1 sub immediate. And then you could also have, let's say, this next bit right here before multiply and divide, which if you do it for add and then make this bit 1, it could be multiply, and then you turn this part into subtract, it could be divide. And then if you make it MOV, it could be some other instruction, and maybe you could make another type of instruction that comes from this sequence as well. And you could also, let's say, select for these first 2 bits to represent the type of instruction. So let's say this is add immediate, and then this is all zeros, and when both of these are zeros, that could represent the ALU, arithmetic logic unit. Well, even though it would actually be both ALU and the FPU, since this bit right here, which converts it into multiply or divide, will represent the FPU, which is the unit that deals with multiplies and divides instead of adds and subtracts. And if you plan on adding a larger set of arithmetic instructions, then the FPU bit could also be moved further back, let's say to be this bit right here. But yeah, at all zeros, it's going to be mathematical operations for these first 2 being zeros, and then you set it to 0-1, it could be memory accesses, such as for loading and storing, and then 1-0 could be for branch, and then 1-1 for the waypoints. Right, and then, so let's get back to addition. And then let's say if you were to do an instruction add and then the destination being R3 and then the two sources being R1 and R2. So these 4 bits right here, and the reason we're doing 4 bits is because 2 to the 4th power is 16, and we have 16 registers, and so it takes 4 bits to represent the register index. So then R3 being the binary of 3, so that will be 1 1, and then register 1, yeah, and then register 2 will be the one back here. And the reason we have all this filler right here is because let's say if you were to instead do a add immediate R3, R1, and then some really large number, and then that number will be represented in here with all this space, and then some of it will also be represented in right over here in these last 4 bits, right? And this is if we're using a 32-bit system. So in reality, it's not actually going to be able to deal with super large numbers because it has over here about 16 bits to spare. And so the largest number you can actually calculate with this is 2 to the 16th power, which is about 655, 35, or 36. Then if it includes the negative numbers, then it's going to be half of that, but it also includes the negative range, so about 32,000 something. And so, to be able to work with the very large numbers, we're most likely going to have to use 64-bit system instead of just 32 bits, since the limit for 32 isn't going to be huge. And yeah, you could use that information to, let's say, create a system of binary where you then modify your program into converting all your instructions into binary code. So just the way. So let's take the add instruction. You take this example assembly code right here. Yep, and then add immediate. There. And then register 3, register 1, and then register 2. And then yeah, add immediate 1. And yeah, this would be, although the real conversion would actually not include these spaces, and only including these spaces here for your convenience to see each different part. So yeah, it would actually look more like this. And more likely it's not going to be separated into lines either. It's going to look like this. And so using just your eye to look at it is going to be pretty hard to tell because of the large number of bits. But the program will have no problem looking through it because it's able to tell 32 characters each time. You could also potentially have it be converted into hexadecimal instead, where let's say take this above set right here and then convert it to hexadecimal. Starts with 0x and then 0, and then over here is 4, so 0 4, and then 3 1 0 0, 0, and then let's change this to a 1, 0, and then 2. Right, now you're on your own from this point forward, and then behind the scenes I may continue to make more improvements to the assembly code simulator and then eventually release it. But also, at the next C programming series I'm gonna make is about data structures, and it's gonna start with 2 data structures, one being an array list, another being a linked list. The third part is gonna be about a binary search tree, and then eventually I'm actually gonna also start working on a chatbot, and it's most likely not gonna be anywhere near as advanced as ChatGPT, because ChatGPT is gonna require some very powerful processors and a very large database, and yeah, over here I'm just doing all that from a laptop. But yeah, stay tuned, there will eventually be a series on data structures, and then after that I'll start working on a chatbot. So see you then.